Earth scientists, we are going to go ahead and get started. So I believe yesterday that we made it through all of the front. Is this looking correct to you? And then we did the volcanoes. We need to do the last two, the EarthSun Relationship and the North Atlantic Deep Water Current, and then we'll be good with this. Awesome. So just to kind of get our brains back in this, my capture question, if I was going to have written one, would be provide a couple of examples of natural causes of climate change. If I had asked you that capture question, what would you have said? Plate tectonics, and by that we mean, right, that when the plates are moving, the continents move, so there's continental shift, so we're changing our latitude, okay? A change in the ocean currents. How do the ocean currents affect climate? I want to make sure you know this, and by that I'm saying that I was just telling Jack that I finished writing the test last night, and I know that there might be questions on that, so just friendly, awareness, and this is something that as students, especially in high school, I want you to be aware of, okay? Teachers often ask you questions because they know that you're going to be assessed on those questions or tested on those questions in the next couple of days or something like that. Does that make sense? So if you listen carefully today, you're going to get a lot of hints about things that might be on the test. So I'll ask the question again. How do ocean currents affect climate?
Because if you're near oceans, it's the regulated temps.
Absolutely. So locations that are near oceans have regulated temperatures, right? You remember we did that graph way back now where we had the temperatures from the three different locations. Remember, it was Cheyenne, Wyoming, and Des Moines, Iowa, and then San Francisco. And remember, San Francisco's temperatures were very, very even because it's right next to an ocean. And ocean currents help to regulate temperature. We also talked about, just a friendly reminder, we talked about how ocean currents, if you have a warm ocean current, then that's going to provide a lot of warmth and also more moisture, right? We did this when we were talking about prevailing winds, okay? And if you have a cold ocean current, then that cold air is going to regulate the temperatures cooler, okay? We also said stuff about volcanoes. Today we're going to focus on the Earth-Sun relationship. So when I ask you what causes the seasons, maybe tomorrow on a test or something, perhaps, might be on there. When I ask you what causes the seasons, is your answer going to be that in the winter we are farther away from the sun? I hope not. You with me there? I hope that's not your answer, because if it is your answer, I'm going to say, oh dear, right? So you know, because remember we measured the sun, that we're actually further from the sun in our summer, right? And we're closer to the sun in our winter, okay? All of that said, the sun, our relationship with the sun does vary a very small amount. And I want to tell you that, like full disclosure, right? This does happen. So I want to tell you a little bit about it. So a couple of quick things here. The first one is that the sun's output changes. I think when we were talking about stars long time ago now, we talked about like the sunspot cycles. Do you remember that? We talked about how that went up and down and up and down. And we talked about solar flares. And we talked about how there's kind of a cycle when the satellites might come down because there's too much energy, too much radiation. Those cycles that are caused by the solar flares also change the output energy that comes to the earth and goes out everywhere. And the cycles are about 11 years long. Okay? At a solar maximum, more energy is output. We have more energy. And when we have more energy, what do you think that that's going to do to the climate? It's going to make it warmer, right? So the way that the sun produces energy affects us directly, okay? The other thing that's kind of interesting about the sun is that we have, I should say the Earth's relationship to the sun, we have a little bit of a wobble. I don't know if you remember on the quiz that we took a while ago that it talked about whether or not the axis tilt changes or varies. And we know from the lab that we did that the axis tilt doesn't change. It's always pointed in the same direction. But full disclosure, there is a little tiny bit of a wobble. But the wobble takes about 23,000 years. So that's not what causes our seasons. Are you with me there? Okay. So there's a little bit of a wobble. It's called precession. Okay. And it's a very small wobble. It's kind of a fun word to say, not going to lie. Okay. In the 23.5 degree tilt. But again, that variation, it doesn't happen every day, every month, every year, every decade. It takes a whole long time for that to happen. As I said, on the order of 23,000 years. So that's not something that's going to affect our climate from year to year. But again, over long periods of time, there will absolutely be an effect. More tilt. Okay. Means that some areas are going to have more direct sunlight, while other areas would have less direct sunlight or more indirect, depending on which way you want to say that, right? So some, oh my goodness. Okay. And others have, we'll say, more indirect. And as we know, because we've been going through this over and over during this unit, I hope it makes sense to you by now that if you have more direct light, what's going to happen to the climate? It's going to be warmer. More indirect light means that it would be cooler, right? So more direct light, warmer. More indirect light, this is always one of those things that I get nervous about telling you because I don't want you to get in your head that the axis is wobbling a lot and that's what causes the seasons, right? This is not seasonal. 23,000 years, okay? We're talking a long time ago. So this is a very slight wobble that happens, but it absolutely does affect our climate, okay? And that's why we see cycles in our climate. And we'll look at those. We'll look at some data about that next trimester. How are we doing so far? Are we okay? Last one. The North Atlantic Deep Water Current. That's a lot of words, or a lot of letters to say. And because, we're kind of lazy, we're going to call that the NADW or the NADWC. The North Atlantic Deep Water Current. So we know that currents flow, right? What causes ocean currents to flow? Do you know? Let me back up a step. What is an ocean current? Talk to your table mates. What is an ocean current? I'm not trying to trick you, not trying to scare you. I want to build this up. You all done, babe?
Decided not to do constellation because I still don't understand. I'm like, there's no point in me doing it and then doing Ghana and everything. So I'll just do it.
So
tomorrow.
we'll study it and then we'll do it tomorrow. Perfect. Awesome. Thanks, hon. And I sent Greg an email before, so just
Okay.
let him know. But I didn't tell him about today. So yeah,
Okay.
yeah.
Can
So
you grab me a pass then?
Yeah.
That might be
for sure. Is that your water bottle back there too?
Yeah. I always forget that.
First,
27? 27? Holy cow. Tomorrow's the last day of February.
Thank you.
it is.
Yeah! 28 days in February. It's not a leap year. I know, right? Friday is the first day of
Friends
March.
are born on the 29th.
Yeah? That's so funny. So even though they're like 16, they're only 4 or whatever. Yeah. You only had a birthday party every 4 years. It's got to be a good one then, right?
What's an example of like a place that has like a volcano but then like reflective clouds?
The ash stuff? Is that what you're talking about?
No, it said like causes like the clouds, sunlight.
Here?
Yeah.
Let me tell you just a second. All right, friends, let's come back together. Sorry about that little hiatus there. I had a quick question about volcanoes, so I'm going to answer that question really quick first so that everybody hears it, and then we're going to go back down to currents because I want to make sure that is okay with you as well. So the question was, what's an example of a volcano situation when it releases a bunch of ash into the air? So there are 2 that I can think of. One is Mount St. Helens. Have you guys ever heard of Mount St. Helens? Yeah, it's a volcano in the northwest part of the United States, and it erupted. Gosh, I can't remember what year. Shamshar could tell us because she used to live there, and so that was like in the top of her brain. But when it erupted, it was not like the biggest eruption ever. Okay, it's not like the most gigantic volcano ever, but because of conditions, it released a ton of ash into the air. And by a ton, I mean ash went up, and actually because of the winds, they got ash from the Mount St. Helens volcano in Europe.
Dang.
So traveled all the way across Canada, all the way across the Atlantic Ocean, like tons of ash. Does that make sense? And so when that ash is up in the atmosphere, it's reflecting the sun's light, so the sun's light is not coming through. And that's an example of when it would be cooler. Now, would that last for a long time? Maybe not in the case of Mount St. Helens, right? It might have been, just like weeks or months. But if it's a really big volcano that's letting off a whole lot of ash, it's giving up a whole lot of ash, then absolutely it could have a much more profound effect on climate. There was also a volcano that erupted in, and now don't quote me on this, I want to say it was in Iceland, and I think it was like last year or the year before. I can't remember all the details, I just remember hearing about it, but I remember that when that volcano erupted, there were airplane flights from all of Europe and then like anywhere to or from that had to be grounded. It was something like for like 3 weeks because they did not have enough control over their navigational tools because of the ash cloud. So like absolutely can have effect, not only on the climate, but on like all of what we know and are used to all the time too. So yeah. But there are some volcanic eruptions where that has no effect, right? So is everything okay? Like I feel like I must have like something hanging off of me or something. Like, are we okay? Did I do something like?
No.
Okay. You guys like chill out then, because I don't know, the giggling like it makes me feel like I have like big boogers hanging out of my nose or something. So if there's something, like tell me, because I don't want to look like a fool. So yeah, please let me know. Okay. Did you guys define current? What is a current? Go, David.
I don't know.
Tell me what you guys talked about.
Beautiful. Not what we thought it was.
Just what a water current is. I don't want to put you on the spot for lots of stuff. I want to build this though because I want you to understand it. You might want to understand it because why, Jack?
Because it is important.
Because it's important. Why? It might be on the test. So let's get it. Got it? Okay. What's a current, David? What did you guys talk about? Way what? The way waves move. Kind of. Yeah, it's not so much waves like surface waves, but it's the way water moves. Yeah. So it's motion of water. And it's not just like bouncy, 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 but it's like big motion of water, right? Yeah. So we talked a little bit, I don't know, a bunch of days ago. Where did that go? Oh, yeah, here we go. We looked at this picture. We saw all these currents, right? We looked at this. Yeah, didn't we? Yeah. And we talked about, so if you don't think you did, then go back and watch the video because some of you recognize this. So I don't think it was just like, just came to you in a dream or something. There are all these currents. So the thing about a current is that it's big masses of water that are moving from one location to another. So that's all well and good. And that gets us a lot of where we want to go. But the thing that I want you to remember is that a current isn't just water moving from one location to another. Because if all of the water in the Atlantic Ocean moved from the equator towards the poles, what would be left by the equator? Nothing. Does that happen? I mean, like it happened in Moana, right, when the ocean parted. But besides that, like that doesn't happen in real life. That was just a movie and it's not real.
I didn't even watch that.
I know. I'm just saying. When you have little kids, that's just a thing, right? Yeah. Yeah. It's great. It's a great movie. Anyway, so the thing that I need you to know is that if you're looking, so if this is the surface of water, this is an ocean. Okay? While the current that we talk about is the movement of water near the surface, if water is moving in one direction, does that mean there's a lack of water here now?
No.
No, I mean, like, we just said this, right? It's not like the sea floor is just going to be exposed.
Yeah.
That's not how water works, right? It's a fluid, right? Something's got to go to make up for it. It's got to cycle, okay? And so there's got to be some water that's coming like this. So it's a big circle, okay, or a big cycle, okay? Now, this flow of water occurs due to changes in our old friend density. Okay? What do you remember about density? What goes up? What goes down? What do you remember?
Warm water goes higher.
So the temperature affects it, right? Yeah, and the warm stuff, because of its density, goes up, and the cool stuff falls down.
Yeah.
Now, there's one, so that's absolutely true, and I'm glad that you remembered that, because that's a big thing to remember. There's something else at play when we're talking about oceans. Are oceans freshwater? No, what are they? What kind of water are they?
Salt.
They're salt water. And salt absolutely affects the density of water as well. Okay? So all of the ocean is made of salt water. It's all made of salt water, but The saltier the water, what do you think? The more dense or less dense? More dense, absolutely. Okay. So we've got down here at the bottom, we've got extremely salty current flowing in one direction. Based on what Hannah just said, do we think that that stuff that's down below is warm or cold? Cold water. Okay? So this is going to be also cooler water. We've also got, so this is less salty up here, okay? Up here, I'm going to put a little arrow into that. Less salty. And warmer. Okay. How does ocean water get warm? This sounds like a really silly question. Where does ocean water go to get warm? Where would it go? Would it go towards the poles or go towards the equator? Towards the equator, right? So this warm water is warmed near the equator, and then it's going to flow this way because you've got this cold, salty water that's flowing from the poles toward the equator, okay? So this over here would be like near the equator. And over here, we're talking about near the poles. Okay? So we got these cycles that happen. This is just true in regular life. This is all well and good. And those cycles help to bring warm air much, much further north than we would get with just direct or indirect sunlight. But one more thing. She's like, we're done. Not quite. Because that's all well and good, but that doesn't cause any sort of climate change. It's interesting that it's National Polar Bear Day. Did you catch that I had that up there? National Polar, and it's National Polar Bear Day, and so I picked a cute picture of some happy, fluffy polar bears. I don't know if you've seen the sad pictures of really, really thin polar bears because they don't have any food, right? What's that being caused by? It's getting warmer up there, right? Yeah? And so all of their ice is melting. Okay? When the ice melts, here's the thing that's important to know. Okay? When fresh ice in the form of glaciers and icebergs, when fresh ice melts, okay, what happens to the saltiness of the ocean? Does it get more salty or less salty? Yep, okay. Decreases salt concentration. And if we don't have the salt concentration to cause that difference in density, then we don't get this same cycle that we are used to and that works for us. Does that make sense? So as a result of our fresh ice melting, it decreases the salt concentration, and as a result of that, okay, the North Atlantic deep water current, okay, does not flow. And that causes changes in not only the ocean currents, but it also causes then changes in the climate of the land near that. Okay. Now you can put that away. Holy cow. Whew. Yeah, we do. That's cool. I want to show you one quick video. It's 5 minutes long. That'll be okay. We're going to do that really quick here. I'm gonna turn some volume on. Hey! Can you hit the lights while you're over there?
The ocean conveyor belt and the Gulf Stream. Ocean currents have a direct influence on our lives. They determine our weather, our climate, and much more. The ocean currents and wind systems transport heat from the equator to the poles and operate like a large engine for the global climate. In the oceans, there are numerous currents. The so-called ocean conveyor belt is very important for our climate. This term describes a combination of currents that result in 4 of the 5 global oceans exchanging water with each other. They form a worldwide circulation system. The conveyor belt is also called the thermohaline circulation, with thermo referring to the temperature and haline to the salt content of the water. Both determine the density of the water. While the masses of water may be moved in part by wind, primarily the different densities of the global oceans are responsible for their movement. Warm water has a lower density and rises, while cold water sinks. The water's density also increases with a higher salt content. At the equator, the heat from the sun is especially strong, resulting in a lot of evaporation and thus a rise in the water's salt content. That is where the Gulf Stream begins. The Gulf Stream is very important for the European climate. Its length of 10,000 kilometers makes it one of the largest and fastest ocean currents on Earth, and it's very warm. At roughly 2 meters a second, it brings up to 100 million cubic meters of water per second towards Europe.
That's really fast.
A constantly blowing wind, the southeast trade wind, drives warm surface water to the northwest into the Gulf of Mexico, where it heats up to 30 degrees Celsius. The turning of the Earth and the west winds then direct the Gulf Stream towards Europe and split it up. One part flows south, another east to the Canary Current, and a third part flows north, where it releases a lot of heat into the atmosphere as the North Atlantic Current. The water becomes colder there. Its salt content and density rise on account of evaporation, and it drops down between Greenland, Norway, and Iceland. There we also find the largest waterfall on Earth, the so-called chimneys, roughly 15-kilometer wide pillars with water falling up to 4,000 meters. 17 million cubic meters of water per second, or roughly 15 times more water than is carried by all the rivers in the world. This creates a strong maelstrom which constantly pulls in new water and is the reason that the Gulf Stream moves towards Europe. Countless species use the Gulf Stream as a means of transport on their trips from the Caribbean to northern areas. But it doesn't just bring us animals. An enormous quantity of warm air also comes with it. In order to produce the same heat which it brings to the shores of Europe, we would need 1 million nuclear power plants. That's why we also call the Gulf Stream a heat pump. Without it, the temperature would be significantly colder here, at least 5 to 10 degrees. Instead of lush fields, we would have long winters and sparse ice-covered landscapes in Europe. In the last few years, scientists and pundits in the media have repeatedly expressed the fear that the Gulf Stream could come to a standstill due to climate change. Because if the polar caps actually melt, the salt content in the water off Greenland would fall, as would its density. The North Atlantic Current would no longer be heavy enough, and so it wouldn't sink as usual. In the worst case, that would bring the Gulf Stream, our heat pump, to a stop. Some climate experts also assume that climate change could compensate for this effect. We know that it can be normal for the climate to change by looking at the development of the Earth over the last few million years. There are ice ages and warm periods. In the last ice age, a gigantic flood of melting water crippled the heat-bringing North Atlantic Current, covering the northern hemisphere in ice. Scientists have different views on the impact that climate change will have on the global ocean conveyor belt. But one thing is clear: when the climate changes, then the complex system of ocean currents and winds, which has remained fairly stable since the last ice age, will change in ways that we don't yet understand.
All right. So hopefully that gave you a little bit more to kind of solidify what we talked about just a little bit ago. That was my hope for it. If you want to watch that again, it'll be up on Canvas or on YouTube later today. I'd like you to get out your climate review guide if you haven't done so already. I think that one was pinned or something like that, right? I wanted to talk about this just really quickly, and then we'll take some time to review, and we can do that in a couple different ways. So, the climate review guide, the reason that I wanted to bring this up with you, number one, I would strongly encourage you to spend some time with it. Okay? I'm not going to collect it. It's not required. But when we write our test, we write the review guide first. And then we try and hit lots of things that are on that review guide. Okay? That's the first thing that I wanted to say. The second thing that I wanted to say, though, is that it's not that if you have an answer for each of these, that you're good. This is intended to get you to look back at what we've done. Does that make sense? So if you look here, they've marked like the Candy Climate Lab, the what causes climate, the climate notes. So what I would encourage you to do, the reason that I wanted to say this, is that instead of just writing, so it says what 4 factors contribute to location's temperature and how do they impact the temperature? So if you just list latitude, elevation, blah, 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 and that's all you do with it, and then you think you're good to go, the reality is that you're not. Does that make sense? This is intended to help you dig into what we've done over this unit, okay? And this unit, we've had a few days of, snow days and goofy stuff like that. So you'll need to go back and look through this stuff to make sure that you've got it. All right? So we have got about a little more than 10 minutes to go before the end of the period. I am happy to let you just work on this. Mrs. Shamshore did create a Jeopardy review game. I don't know if there's anyone who is interested. If there are, I would be happy to play Jeopardy with you. So is there anybody that would like to do that, or do you want to just work? Jack's like, yeah. You want to do it? All right, so I tell you what. If you would like to play Jeopardy, why don't you come to this table and this table, like these 3 tables? And if you do not want to play Jeopardy, then move somewhere else. But here's the thing, friends. Regardless of where you're at, you need to make sure that you're working on earth science. Okay?
Jake, do you want to do Jeopardy? 7.
You do Jeopardy?